So I'm Ayala from Tel Aviv University, and this is a joint work with Amnon Maltz from the University of Haifa. Our starting point in this project is that when making a choice between a number of alternatives, some of the alternatives dimensions are more salient and they receive more weight in the decision-making process. And we are interested in what makes a dimension more salient. And we also suggest a particular new channel for affecting a dimension salience and decision weight. So in order to illustrate the main idea of the paper, I want you to consider the following scenario. Suppose that you just received $2,500 from your workplace, and your boss offers you 3 options to transfer the money. The first option is a checking account. The second is a saving plan with 4% yearly interest, which you can take the money out once a week. And the third option is a stock that with 50-50 chance can rise or fall, so you can earn 40% or lose 5%, and you can also sell the stock whenever you want. So think about this set. And I also want you to imagine what would you do if I told you that the checking account carries some very small interest rate. So actually in one of our experiments, we compare between behavior in these following 2 choice sets, one with a checking account that carries no interest rate, and the other in which the checking account carries 2% interest rate. And we also have these 2 choice sets that we compare between, in one of them 0% and in the other 0.1% interest rate in the checking account. And the saving and stock is as I described before. So the question is whether this small change in the interest rate in the checking account makes significant change in behavior. One possibility is that it's a small change and nothing will happen when we will add this interest rate to the checking account. Another possibility, the standard one probably, is that when we add interest rate to the checking account, we improve it and more people will choose it because now it's not only liquid, but also provides some revenue, even if it's a small revenue. But of course, we would like to suggest the more surprising effect. We suggest that the opposite happens. When the checking account carries no interest rate, then it is perceived as the most liquid option. And if you highly value liquidity, you will actually choose it. But when we add the 2% interest rate, the perception of the checking account changes. And now what is more prominent is the safe gain dimension. So we say that the safe gain dimension is turned on in this option in the checking account when we add this 2% interest rate. It means that it immediately comes to your mind when you think about this checking account. And since it is more prominent, liquidity is shrouded. And now this prominence of the safe gain dimension is relevant for your evaluation of the other options as well. So when you look at the red choice set, when you evaluate saving and stock, then the safe gain dimension become more important than it was in the parallel blue set. So it can affect your evaluation of the other options, and we will suggest that people will choose more the saving option in the red set because it has a larger safe gain than the checking option. So this is a violation of monotonicity. I mean, we'll have a between subject design, but if a person that chooses the checking account when it has no interest would choose in a parallel world the saving account with the 4% instead of the checking with the 2%, so we improve the checking and he moves to another option, this is a violation of monotonicity. The main idea of the paper is, I think the focus is to show experimentally the effect of turned on dimensions. We explore 2 channels for turning on dimensions. One of them is to change the value of the dimension, like we did in this example with the checking account. So taking a 0 interest rate and changing it to a positive number will turn on this dimension of the safe gains. Another channel that we talk about in the paper is turning on dimensions by framing, that is by describing the alternatives in a different way, making one dimension more prominent. But I think I will not have time today to show you the framing example. We also show that existing models of salience and focusing cannot explain our findings in the experiments, so we suggest a new model to accommodate the finding. But again, I don't think we'll talk about the model today. So let me start by describing the psychological procedure that we have in mind. I'll distinguish between positive and negative dimensions of alternatives. So positive dimensions is something like the interest rate on the checking account, cashback on a credit card, or years of warranty on a new product. How do you turn on a positive dimension? You give it a positive value. So we will say that the positive dimension is turned off only if its value is 0. And any positive number will turn it on, just like the checking account where it was 0, the interest rate in the checking account, it was turned off, the safe gain dimension. When we change it to a positive interest rate, even a very small one, we turn on this dimension and it becomes more prominent. For negative dimensions, like the temporal distance of obtaining a price now versus the future, or distance from the apartment that I consider renting to a swimming pool, for these dimensions, actually, when we emphasize the positive facet of this dimension, this is where we turn them on. So we suggest that the negative dimension is turned on only if its value is 0, and otherwise it is turned off. So if in my building there is a swimming pool, then the distance between my apartment and the swimming pool is 0, and then this dimension of distance to the swimming pool is turned on. Otherwise, this will not be an important consideration in my decision-making which apartment to rent. And so this is a distinction between positive and negative dimensions, but in both cases, when you emphasize the positive facet of the dimension, this is where the dimension is turned on. And now, how do you combine this understanding of what dimensions are turned on and off? Weights of different dimensions are determined by the instances in which a dimension is turned on. So if you turn on a dimension in more alternatives, it is more prominent in more alternatives, then the weight that this decision, that this dimension will get in the decision-making process will be larger. And it's important to note that these weights are applied to the assessment of all alternatives in the choice set. So you look at an alternative and you can say whether dimension is turned on and or off there. But if I turn on a dimension in a particular alternative, it increases the weight of this dimension also when evaluating other alternatives, not only this particular alternative. So it can affect how we assess other alternatives in the choice set. So this is the psychological procedure. And I would like to start with an experiment that used the example from the illustration from the beginning. It's an online experiment among Israeli panelists, and they face this hypothetical scenario that they get a bonus. Here it's 10,000 shekels, roughly equivalent to the $2,500. And they get this money and need to decide where to put it, in a checking account, in a saving plan, or in a stock, just like before in the illustration. So it's a between subject design. We have two treatments. In one of them, 0 checking account, 0 interest rate. And in the other one, there is 2% on a checking account, but the other two options are the same in both treatments. Okay? And we would like to see again how behavior differ between these two treatments. We pay them 5 shekels for participation, but it's an hypothetical scenario, so it's not incentive compatible. And the average completion time was 5 minutes. We have about 200 participants, 100 in each treatment. We gave them a little more details on these options. So we mentioned that some checking accounts have interest rate and some don't in reality. And for the sake of the experiment, they should imagine that they have the checking account that we described in the experiment. For the saving, we explained that every week they have a weekly withdrawal option. They can call or come to the bank to take out the money or part of the money. We also explained that the 4% are for a year. So if you take the money earlier, you get the relative sum. And similarly with the stock, you have immediate withdrawal option by phone or by coming to the bank. So it's very liquid. And again, you can get the relative sum if you take the money earlier or part of the money. So these are the details that we gave them about the options, and they had to choose. Later, they will ask to explain why they chose this option and another test that I will explain about later. So first of all, the results of the 0 checking treatment. Here, when the checking account has 0 interest, 23% choose it, 50% choose the savings, and 27% choose the stock. Let's compare it to what people do in the 2 checking treatment when we add this interest rate. So you can look at the right side. Here is the 2 checking treatment. And what you can see is that the percentages that choose the checking account when you add 2% interest rate decreases from 23 to 11. And this decrease translates into an increase in the savings option. So people that do not choose the checking now choose the savings instead. And it's important they don't move to the stock. The stock is not different between these two treatments. It's consistent with our explanation that the safe gain dimension is more prominent in the two check-in treatment, and the savings has this safe gain dimension. It's actually very good in the safe gain dimension. So people move to this option and not to the third option of the stock that doesn't have a safe gain dimension at all. We also see some support for our for this pattern in the 0.1% experiment. Again, similar experiment. It's just that the checking account now carries 0.1% instead of 2. So we see the similar pattern. And when we look at the explanation that people provide for their choice, we can analyze them and see whether they mention these dimensions that we talk about. So we let 3 research assistants go over the explanation and classify them. And in particular, we asked them to mention whether there was an indication of safe gain or liquidity in the message, in the explanation of the subject. So we count how many safe gains mentioned and how many liquidity mentions were in the explanation of the subject, and we see that it differs between the treatments. So indeed, again, in the right side, you can see the 2 check-in treatment. So you can see that safe gains are mentioned more often in the 2 check-in treatment when you add interest rate to the checking account, and liquidity is mentioned less often. As we said, liquidity will be shrouded because the safe gain dimension will become more prominent when we add this interest rate. So the explanations support this idea of prominence of dimensions that we suggest. The second task that we ask them to do is to imagine that they can allocate the money of the bonus to these 3 options and they don't have to put everything in one place. So it was after the choice. I will say in advance that it's a weaker result because of that. It's after they made a choice before, but they need to allocate it, and we look at the proportion that they put in the checking and in the saving account when we change the interest rate from 0 to 2. Here are the results of the saving. The proportion allocated to the saving plan increases when we move from 0 interest rate to 2% interest rate, and it decreases in the, it decreases in the checking account. Again, no change in the stock. So they made a decision after they made a choice between the 3 options, and therefore I think some of them probably wanted to be consistent somehow with their choice, and it's a weaker result, but I think it's still a nice example of this pattern. Let me spend a minute on explaining why other existing models of salience and focusing cannot explain the findings that we see here. So if we look at Kojegi and Zeidel's framework of focusing, their idea is that weights of dimensions are determined by the variance within the dimension. So when you increase the variance within the values of the dimension, the weight of this dimension increases. This dimension becomes more important in the decision-making process. In our experiment, when we change from one treatment to another, from 0 interest rate to 2% interest rate, we actually decrease the variance of the values of the safe gain dimension. So according to their model, this dimension of safe gains should become less important. And also other models of salience like Bordello, Genioli, and Schleifer's model of salience, they have similar prediction to the focusing model. And our finding are that people choose more the option with this good safe gain dimension with the 4%. So their models cannot predict our findings. Let me move to the second experiment to show you how we can turn on negative dimension. And the context will be different here. We look at distributive preferences. So here again with Israeli panelists, it's the same Israeli panelists, an online experiment. We ask them to rank 3 options of allocations between themselves and another anonymous other from the same panel. Between subject design 2 treatments. In the first treatment, we call it the equal treatment. We have an equal split, option A, 100 each, and then 2 unequal allocations. And in the unequal treatment, all the 3 allocations are unequal, 100, 130, and the same B and C as in the previous treatment. So again, we only changed the first option. I don't know whether A prime or A, which of them is better. Maybe some people prefer efficiency, maybe some people prefer inequality, but I will be interested actually in the ranking between B and C. So I make a change in the first option, and I would like to see how it affects the evaluation of B and C. And our idea is that 100, 100, the equal split, turns on the inequality dimension, because there is no inequality. The inequality is 0 in this option. So it is turned on, it comes to our mind, it becomes important. And then when we evaluate the other options as well, we think about this inequality dimension more. And if inequality becomes more important, then option B, 100, 140, becomes better than C. So its relative attractiveness compared to C increases. So we would like to see B above C more often in the equal treatment. This will be consistent with our idea. We had 400 panelists here. We had 2 treatments, but in each treatment, we also randomized the order. And we paid them 3 shekels for completing the survey, but also 1 out of 20 people got the, according to his choice, got the money, the 100 shekels that he should get, and the other one, whatever he allocated to him. How did we incentivize the ranking? We told them that with 60% probability, they will get the first option that they rank, and with 40% probability, they will get the second best that they rank, so it should incentivize the complete ranking. And it took them about 3 minutes to complete the experiment.
That's 15 minutes.
Sorry?
15 minutes in.
Okay, thanks. So the main interest again is how many times B is above C in these 2 treatments. So on the right, you can see the equal treatment where we think that B should be ranked above C more often, and indeed there is an increase of 40% there. You can probably see that still most of the people care probably more about efficiency, and they choose more often C above B, but the increase in B above C is very obvious here in the equal treatment. And we look at the explanation here as well to support our idea. And in the explanation, we look at efficiency and inequality, which are obvious dimensions in this context. We see that the blue one is efficiency. So we see that indeed most of the people mention efficiency, but in the equal treatment on the right, we see that less people mention efficiency and more people mention inequality in the red. So again, consistent with our idea that the equal split turns on, make the inequality dimension more prominent, more important for decision-making, more important, it's reflected in the explanation at least. All right, so this was a reverse of preferences between 2 other alternatives when we changed the first alternative. Now let me jump to the conclusion. So we suggested we can turn on and off dimensions by changing a little bit the value, and I didn't have time to show you the framing idea, but it's really small manipulation that can do that. And when we do this turning on, then other dimensions are shrouded and become less important, get less weight in the decision-making process. And this phenomenon can lead to preference reversal or violation of monotonicity. Now, we just emphasize this discontinuity around the 0. We emphasize this feature that affects salience, but we don't think that it's the only feature that is important for salience or for decision weights. Of course, that the variance of the values of the dimensions are important as well, and then models such as the focusing model and the salience and relative thinking models can fit well and make nice predictions. So for example, if all dimensions are turned on in a context, then our model becomes not important, and then you can take one of these other models and use it to predict the weights. So our model is an addition to these existing models. All right, I think I'll end here and let you ask me a question.
Okay, thank you. We still have, yes, no. I'm trying to figure out. So we still have time, right? We have 5 minutes for questions. Any questions?
Yeah, if no one else.
You go first.
Okay. I just wanted to know, like, one thing in terms of numbers. Did you have more people choose B or C for the social preference? Like you showed us the relative ranking for the social preferences, but the total number of choices for the first one with the stock. So
wait a second. So you're talking about the first experiment or the second?
I want the numbers for the social one.
Okay.
You showed us the relative ranking of B versus C, but not the total number who chose. Like maybe I misinterpreted 18 versus 32%, but my understanding was that of the people who chose.
So it's a ranking. Remember, they also need to rank the first one. So most of the rankings are monotonic. Not all of them, but most of them are monotonic. So people
Oh, they gave you ranking. I'm sorry. I thought they made a choice. So
Yeah.
they only told you their favorite.
But I think it's very similar because most of the choices are monotonic. So they rank 100, 100, and then 100, 140, and so on, or the other way around.
That's fine. I just thought this was actually of the people who chose B or C who preferred B. So I misunderstood. Okay, that's fine.
Okay.
Yeah, and I think in terms of framing, like what you said at the end about focusing and salience, I think that the way to at least theoretically, if not empirically, differ is really this turning on of the dimension, as in focusing and salience are about distorting. Everyone takes every dimension into account, but they distort it differently. Where sort of what you find is that term in the sum, this dimension is only added when it is different between any options in the set, but it's ignored if it's constant for all of them. So I think conceptually, it makes it clear why they're complements. Because we could have focusing on top of the turning on if multiple options now lead to different ranges. And so that makes it clearer how those two are literally complements.
I totally agree. Other questions?
I had a question. It's a very interesting talk. I was wondering how much have you checked the robustness of this? Like, do you have to sort of keep things simple to get, because you get quite a strong result? Or like what I'm looking at is that if you actually increase the likelihood that they're being paid by their decisions, do you observe that the result size that you get gets smaller?
You mean if I incentivize them completely, like everybody will get the money?
Yeah.
Well, we don't have such an experiment. So I don't know, but my hypothesis is that it will not change the results. I thought you mean by robustness, like maybe how prominent it is that, for example, if I have many options and only one of them in which I turn on something, will people notice it, that I turned it on? So I don't know, we did not, well, the experiment that we have here, we have 3 experiments. These are the experiments in the paper. I think it's an important topic, so it's worth exploring the robustness of it.
I agree.
If no one else has another question, I was just wondering, you didn't show your theory, but it seems in some sense very similar to implicit preferences by Cunningham and de Quid. I don't know if you know that.
What is it?
Thomas Cunningham and Jonathan de Quid, they have a paper, working paper on implicit preferences. So the idea there is, you know, who do you prefer between a male physicist, a male economist, a female physicist, female economist? And if, say, I am a chauvinist, but I don't want to show it, then when I choose between a male physicist and a female physicist, I choose the female to hide it. But when I choose between a male physicist and a female economist, I choose the male, pretending that I prefer physicists. But if you then choose a female physicist and a male economist, I now again choose the male, even though that means that I must prefer physicists to economists and economists to physicists. And their focus is on implicit preferences like this, but they also mention that lexicographic preferences and like turning on a dimension is the thing that leads to their implicit one. So
it sounds very similar. So what is the psychological mechanism there that they describe?
They actually say they give a revealed preference model where it's like if choices are different in that dimension, it's less revealing of my implicit preferences. And then they say it could be that I'm not aware of them. It could be that I'm trying to hide them either from myself or someone else. And when I choose directly, when people are only different in gender, then I'm really revealing my gender preferences, right? Whereas when I have another dimension that is different, I can hide it. But they do mention that sometimes of framing effects can, of course, also lead to this. So like joint versus separate evaluation, where maybe you're not hiding, but it leads to different weightings. But they are kind of agnostic about it. But I think their framework is very, we use it because we're interested in people making excuses for present bias. That's how I came across it.
Okay.
So, and it formalized a lot of, it made lots of things clear that we had thought about slightly less clearly because we had just thought about the experiment. But anyway, worth looking into maybe.
Yeah, it sounds very similar.
Okay, so thanks. We need to switch to the next talk, and it would be interesting to continue this at the Hangout. So,
I'll have to leave, but good luck.
Bye, Mark.
Okay, cheers, Mark. Okay, Nicholas, can you share your presentation? Okay, you're muted, Nicholas. Okay, so we'll continue to the next. Go ahead, floor is yours.
Okay, so my name is Niklas and I'm from the University of Potsdam, and today I want to present my research project, which is called Vicinity Bias, and this is joint work with Lisa Bruttel. Oh, it's not working. Oh, sorry. So, yes, if individuals have a choice between receiving a smaller but immediate amount of money and a larger but later one, they often prefer the smaller but sooner one over the larger but later one if the difference between the two payments is not too large. However, if we add a constant temporal delay to both payment dates, these preferences often reverse. Then the larger but later one is preferred over the sooner but smaller reward. And this is an example of time inconsistent behavior triggered by present bias and widely discussed in the literature. And in this research project, we ask ourselves whether a similar pattern in the spatial dimension analogous to the temporal dimension occurs. To answer our research question, we focus on spatial preferences for goods which have existence values. So these goods have rather an intrinsic than a direct use value for the individuals. And we think that we can disentangle spatial preferences from other preferences like reduced transportation costs if the goods are located nearby, if we focus on these goods which have rather an intrinsic than a direct use value. So in this regard, we guess that charitable goods are associated with existence values because people like to donate due to intrinsic motivation, and without aiming at using these charitable goods provided directly by themselves. And interestingly and important for our research design, charities often implement the same projects at different locations, so provide the same charitable goods spatially different, and also enable donors to select their preferred project location. And I've got two examples here. One is SOS Children's Villages in Germany. The other one is Atmosphere. For instance, here at SOS Children's Villages, there is one nation project which is called Dorfpatenschaft, and this is carried out in different regions. And potential donors have the opportunity to choose one location due to their spatial preferences and send their money to this location. We implemented an experimental design at two lab locations at Plex Potsdam and DICE Düsseldorf about the spatial provision of charitable goods, whereby we decided to choose two different lab locations to ensure if there is any effect, it is not a certain Potsdam or Düsseldorf effect. So in our experiment, they participated in two experiments, experiment 1 and experiment 2, which I explain in a minute, and made decisions. And one of the decisions they made about the provision of charitable goods was randomly chosen and implemented by us. So our research design was consequential. In experiment 1, we introduced 3 different donation projects which we believe hold existence values. These projects were oil protection, assistance to children in need, and cancer research. Interestingly, each of them takes place in 3 different regions, whereby we define as region A, this region, which is in the immediate vicinity to the participants. Region B is about 250 kilometers away, and region C is about 500 kilometers away from the decision maker and about 250 kilometers away from region B. So for those attending Plex Potsdam, Potsdam and surrounding area is their region A in their immediate vicinity. Hanover and surrounding area is about 250 kilometers away, and Düsseldorf and surrounding area is about 500 kilometers away from the participants. For those attending DICE Düsseldorf, Düsseldorf and surrounding area is their region A, Hanover and surrounding area also region B, and Potsdam and surrounding area their region C, about 500 kilometers away. In experiment 1, the participants had to distribute 12 euros between 2 locations which carry out the same donation project. And they did it in 2 treatments. In treatment 1, the locations were in region A and region B. Please keep in mind, in treatment 1, the immediate vicinity is involved, and between region B and region C. All in all, they made 6 decisions in experiment 1. So we've got 3 different donation purposes and 2 treatments, so 6 decisions overall. And with this experimental design, we wanted to test the following 2 hypotheses. The first one was that individuals prefer, in general, the provision of charitable goods nearer, which would be if they prefer the closer donation projects in both treatments. And our hypothesis 2 referred to the special effect of the immediate vicinity, because we said the preference for the closer donation project is more pronounced in treatment 1 compared to treatment 2.
I just asked, just to clarify, so
Yeah.
they see the same in B, in location B, they see the same project in the same location twice, but once they compare it to the close and one to the far, right? Did I get it right?
So in treatment 1, they made 3 decisions and 3 decisions in treatment 2. So for instance, one decision is 1 charitable project, oil protection carried out in 2 different regions, and they had to split up between.
Yeah. So I mean, let's say owl protection in Hanover, they saw this twice, right?
So yes, they saw it in treatment 1. There it was, yes, B, and in treatment 2 where it was B as well. Yes.
Yeah. Okay. Thanks.
Okay. So, and this was the first experiment, and then I want to come to the second one. So our experimental design in experiment 2 is very, very close to experiment 1, but there was one important exception. In treatment 2, there was no fixed budget to distribute. Instead, the total sum of the donation was dependent on the spatial distribution. So we implemented a trade-off between giving more to one location on the one hand and giving as much as possible on the other hand. So I will explain the underlying mechanism now step by step. Here we've got the different choices which are possible for one decision maker. If he splits up the money equally between location 1 and location 2 and both carry out the same donation projects, this maximizes the total donation because each location receives €6 and in total charitable goods at the extent of €12 are provided. If he decides to give 1 cent more to location 1, the donation to location 2 decreases by more than 1 cent. So all in all, the total donation decreases. And the stronger I prefer giving to one location, the larger the amount of money I have to give up in total in exchange for giving 1 cent more to location 1. This is what we call the marginal efficiency loss, which we measure with this procedure, the maximum of money, amount of money one individual is willing to give up of the total sum of the donation in exchange for giving 1 cent more to one location. And with this procedure in experiment 2, we want to test the following hypothesis. 3, the marginal efficiency loss due to spatial preferences for the nearer location is large in treatment 1 compared to treatment 2, which would mean that they provide nearer, but in total smaller charitable goods if the immediate vicinity is involved. And these preferences would reverse once the immediate vicinity is not involved anymore. Now I want to come to the results. First, for experiment 1. Here we've got decisions across all donation purposes where I control for subject mixed effects. We've got several control variables. For instance, treatment 1, we controlled for use values associated with the donation projects at the different locations. We controlled for the kind of information they had about the different donation purposes at all locations before making their decisions. And our dependent variable is, for experiment 1, the donation given to the closer project minus the equal share. So what do they give more than €6 to one location? And we had these two hypotheses. So individuals prefer the closer donation projects in both treatments. Where do we find no support? Because if the immediate vicinity is not involved and they had to decide between distributing money to a location which is about 250 kilometers away or 500 kilometers away, they split up the money nearly equally. However, if treatment 1 is involved, they provide nearer donations and charitable goods. So support for hypothesis 2. And we find this support across all donation purposes. So if we look into the data for each donation purpose separately and for both lab locations. Now I want to come to the results of experiment 2. We've got the same control variables as before, but now our dependent variable is the marginal efficiency loss due to spatial preferences in cent, whereby a positive value implies that the individuals are willing to give up a certain share of the total donation for giving more to the nearer location. And negative values would imply that they are willing to give up a certain share of the donation to provide more distant charitable goods. And what we can see here is the marginal efficiency loss due to spatial preferences for the nearer location is larger in treatment 1 compared to treatment 2. And we find this support also for each donation purpose and for both different lab locations if we look into the data sets separately. So now I want to come to an example which, so the results of experiment 2 imply that if the participants in our experiment have the choice between giving €1 to the nearer donation project, which I define as option X, and €1.50 to the distant donation project, which I define as option Y, they would choose option X in treatment 1 and option Y in treatment 2. So their preferences would reverse due to vicinity bias, and as a consequence, they would prefer to some extent smaller but nearer charitable goods over larger but more distant ones if the immediate vicinity is involved. But these preferences would reverse once immediate vicinity is not involved in anymore, and then they would do more efficient decisions in terms of providing as many charitable goods as possible. And as a consequence of our results, we can say that due to vicinity bias, less favorable goods as possible are provided. And of course, this has negative consequences for the public welfare. Thanks for your attention.
Okay, thank you. So we have now 10 minutes. Any questions, comments?
Yeah, what is area B?
Area B is Hanover and surrounding area.
And again, where is Düsseldorf and Potsdam? In A and C?
Yes, so no, it depends on where the participants are. So for attending Plex Potsdam, Potsdam and surrounding area is their region A because it's in their immediate vicinity. For both lab location and the participants Hanover and surrounding area, because it's in the middle of the two, it's region B. And for those attending DICE Düsseldorf, Düsseldorf and surrounding area is their region A, and Potsdam and surrounding area is their region C. So we measured preferences from two directions.
Yeah, but B is the same.
B is the same, yes, correct.
So could it be that B is the issue?
Please, could you please?
I mean, it seems like the preference towards B are weaker in a sense, or?
Yeah, you can reverse the framing. Say they always choose between the close and the center, and between the center and the far. So everybody makes exactly the same decision. They're just called, the treatment one for one group is the treatment two for the other group.
Yes, correctly. So it's, yes, I have to think about this. So yeah.
Maybe it would
Me
be
too.
clearer to present it this way. Okay, Ayala, one. Yeah.
Yeah, I'm not sure I see the, it's not exactly parallel to the intertemporal choice experiment, right?
Well, it would if you could ask, if you could go back in time, right? This is two-directional. So with time, with temporal, you cannot ask what would you prefer yesterday or a week ago.
Mm-hmm.
But here they can make the comparison. But it's like if you ask between the beginning, middle, or end of the month, and some people you ask them at the beginning of the month, and some people you ask them at the end of the month, and everybody likes to get it now. But that's, you know the story about Gideon Schwartz at the Hebrew University?
Yeah.
In statistics class, one of the students said that physicists have shown that you can move back in time. And Gideon said, that's very interesting. Can you tell us more when we meet last week? Yeah, I have a few comments and then we can go back if it's okay.
Okay, please.
So one thing, this has the flavor of construal level theory. It's not absolutely clear to me, but I think you might want to look at that literature and look at the direction, because in construal level theory, they talk about psychological distance, and psychological distance can be in time or in or spatial distance or social distance. So you see the same pattern when you ask about now and later, or here and somewhere else, or about someone close to you and someone far away from, or someone, you know, socially distant. So it would be interesting to look at that. I have got, so at the end you said it's, you said preferences reverse, but it's not, you're not asking about the same options. So
yeah, please go ahead.
Yes, I don't see how the preferences change.
Okay, so with this marginal efficiency loss, our mechanism to figure out whether they are more efficiency interested if the immediate vicinity is not involved. So if they have a choice at, so as I explained here, between €1 to the nearer project and 150 to the distant project, then if the immediate vicinity is involved, that is what our experiment.
But preferences are defined over outcomes, and option X and Y are not the same in treatment 1 and in treatment 2. That's my comment. So it's not that they prefer Hanover in one treatment and over Potsdam, and Potsdam over Hanover in a different treatment. So and that's what I would call preference reversal.
Okay, so I would say that they prefer the nearer, so giving €1 to the nearer donation in treatment 1 and 1.50 to the distant donations in treatment 2. Yes.
Yes, but nearer is not an outcome. So it's not that the preference reverse. And relatedly, I think, so your last point here is about welfare. And of course, by definition, their welfare increases by what they choose. So it's hard to talk about negative consequences for public welfare. You can talk about, you know, monetary efficiency or the efficiency of the donation.
Okay.
But if they choose something which is less efficient in money, it means that their utility is higher, their welfare is higher. So it's, strictly speaking, you cannot say that it reduces public welfare. But formally, it increases the welfare of the decision maker, by definition.
Okay, but at the end, in total, less goods are provided by the.
So I think I'm just saying welfare is usually about preferences. So it's better to talk about efficiency, which is more objective.
Okay. Okay.
And last comment, and then see if I realize something else to say. There is a Talmudic rule, right, in Jewish tradition that says you should give to the poor before the rich. You should give to the poor from your family before a poor not from your family. And you should give to the poor from your city before a poor man who is not a relative from another city. So if you want like a nice quotation for the paper, you can look it up.
Okay,
that's
you.
In the Talmud.
Okay.
Okay. Ayala, was there, you want to get back to your comment?
No.
Okay, so formally we have about 2 minutes.
So Nicholas,
yeah,
maybe this is a related literature that you can touch on. So there's something in finance about this home country bias, that people who invest in their own country, even though they can get better returns by investing in other countries.
Yeah.
So that seems to draw parallels to this proximity.
Okay.
That may be helpful.
Okay. Thank you, Lawrence.
Okay. Thanks. Guess, we can move on. We have 1 minute before I'm supposed to start. I guess we can start. Let me share my screen. Okay. Can you all see the screen?
Yeah.
Okay, good. Okay. Good. I'll start then. Okay, so no, thanks for sticking to the last presentation of the last session. But I guess we have only the speakers and co-authors. Okay, so I'm going to present, this is work in progress with Aniol and Santiago. If you've seen George Lovenstein's talk at the beginning of the conference, he started from something somewhat similar statement here, that traditionally in neoclassical economics, the value of information comes from being useful, that it's going to change your decisions. And George went on to talk about belief utility and then attention utility. So this paper is in the world of belief utility, right? But we start with, but the standard theory says information has value, which we'll call instrumental value, because it's going to affect your actions. Depending on the information you get, you're going to make different decisions. And now there's lots of evidence for non-instrumental value for information, right? So like George mentioned, the anticipatory utility, or maybe people don't like to hear bad news, they prefer not to hear it. Almost all of these papers looking at non-instrumental value, they looked at in a context where there is no instrumental value. So either people don't have any decision to make, or they're going to make the same decision regardless of what information they get, right? Which is a good way to identify the existence of non-instrumental value, where you can really rule out any instrumental value. But what we want to do is go a step further and look at non-instrumental value in a setup where there is also instrumental value and see how these things work together. And the other thing is that to really identify non-instrumental value, we need to look at it from the point of view of the decision makers, right? So it's possible that we see that somebody picks the wrong kind of information given what we think has value, so we call it non-instrumental, but actually it's possible that just people have the wrong beliefs, and given their beliefs, they expect this information to have instrumental value. So we need to correct for all kinds of errors in belief updating and look at things from people's subjective perspective. The context we're going to look at is biased information sources. So let's say you want to know whether the Trump administration is doing a good job handling the pandemic. Who should you listen to? Well, MSNBC has no value for you, which is okay. Because let's say you're going to vote for Trump. Even if MSNBC are going to say he's doing a terrible job, you're not going to change your mind, because you say, well, they always say that. There's nothing new. But only if something like Fox News is going to say Trump is doing a terrible job, that might make you change your mind. So that has instrumental value. And that's a well-known result in the literature, that instrumental value is higher for information sources that are biased in the direction of the prior. So it's like confirmation bias, but just driven by instrumental value. What we're going to look at is unbiased sources. So you might disagree with me that this is unbiased, but just for the sake of the example, an unbiased source is a source that doesn't always get it right, it sometimes makes mistakes, but the mistakes are the same in both directions. So we're going to look, there are papers looking at biases in both directions. We're going to look at biased versus unbiased. So in the experiment, participants are going to choose between an unbiased and a biased source. And what we do is we're going to keep the two sources the same, but vary the prior, and by that we can manipulate the instrumental value. We also elicit beliefs. So as I said, we want to look at value given the subjective probabilities. And I don't have to explain it here, but we use abstract environment in the lab. There's no motivated beliefs like in political situations. It's just balls and urns. So everything is driven just by the information characteristics of the sources. And this ties into several literatures. As I said, there's literature on instrumental value. There's largely separate literature on non-instrumental value, looking at situations where there is no instrumental value. And because we're going to look at belief updating, this ties in also to the belief updating literature. So for lack of time, just go into the experiment. So there are two states of the world. We'll call them red and blue. So we say there is a triangle. It's either red or blue, and the prior is given by rho. and then participants need to guess the state of the world. If they get it right, they get a prize. So it's just the probability of getting it right. There are two advisors, we call them U and B. Now U is the unbiased, so it always sends the right signal with the same probability in both states. And the probability can be the informativeness of the unbiased can be 60% or 75%. This is going to be a treatment. The biased source really likes to say red. So if the true state is red, it's going to say red almost for sure, 95% of the time. But even if the true state is blue, the biased source is going to say red half of the time. And so for any state of the world, the biased is more likely to say red than the unbiased. In that sense, it is biased towards red compared to the unbiased. So here it is graphically, right? So what we have is the priors on the x-axis and expected payoff on the y-axis. So if you have the unbiased in this example, gives you is correct 75% of the time. If you do what the unbiased tells you, then you're going to get it right 75% of the time on red, 75% of the time on blue. So whatever the prior is, this is going to give you expected utility 75. So I'm going to use expected utility interchangeably with expected payoffs in this context. The biased, if you follow the bias, then on a red state, you're going to get it right 95% of the time. But on a blue state, you're going to get it right only 50% of the time. So as the prior goes up, as it's more likely to be red, the value, or sorry, the expected utility of following the bias goes up. That means we have this threshold prior here above which the biased is better, below which the unbiased is better. So should people follow these signals? Well, the answer is no. Sometimes you should just ignore it. If the priors are very extreme, of course, if you know that it's red for sure, then you should ignore the signal and just guess red. Right? So the instrumental value of a source is defined just by the improvement in expected payoff beyond what you can get by just following the prior. So here we have the prior in black. So from following the prior, you're going to get the expected payoff shown in black, which means that the shaded areas with very low prior, you should just guess blue. Very high, you should just guess red. All in between, you should really follow the signals. So if you look at the unbiased, the green, for low priors, it's going to have 0 value because it has no advantage over following the prior. Then it's going to have the highest value. Then it's still going to have value here. It's going to still have value, but less than the biased. And above this point, it has 0 value. So value, when you move the priors up, the value of the unbiased goes up and down. And we'll get back to that. Okay, the important point here is that when does an information source have value? Only if the posteriors are on both sides of 1/2. Only if you get a red signal, you're going to guess red, and on blue signal, you're going to guess blue. That's the only case it has value. And if you're going to guess the same thing regardless of what the source tells you, it doesn't have value. Okay, so the design is this. The main task is they choose one of the source, they get a signal, they make a guess. But remember, we want to track the decision process. Now, the expected utility is just for a source is the probability I'm going to get a red signal multiplied by the probability that this signal is correct, plus the same for blue. So we're going to track that. So after the first stage where they choose the advisors, get a signal, or actually do it strategy method, make a guess for each possible signal, they move to a second stage where we elicit the posteriors. And after that, there's a third stage where we elicit the probabilities of each signal given the source. I'll show you in a minute how it works. At the end, we have some questionnaires. Treatments are the informativeness of the unbiased source, 60% or 75%. That's between subjects. That's different groups. Each subject sees these 4 priors, 10%, 40, 55, and 75%. They play 10 periods for each prior. So a block of 10 where the prior is fixed, and then they switch to the next prior. This is randomized. The colors of the priors are randomized. Within and between, everything is randomized. And they get paid for 2 periods per block. So here is the full design. We have the treatments, 60% and 75% for unbiased, and the dashed vertical lines are the 4 priors. So what I want you to see here is that for the low prior, for example, here, none of the sources has value, and it's the same with in the other treatment, but the difference in expected utility changes. We have situations where both of them have value, but one of them has more value. We also have situations where only one of them has value, or both have value and they have exactly the same value. So this design sort of covers the whole terrain. This is what it looks like. So on the top, you see here the prior, right? So in this case, the colors are orange and purple. The prior is 75% orange. You see the two sources. The biased happens to be in the top. You see that the bottom is symmetric. That's the unbiased. They see this, they choose a prior, in this case, the biased, go to the next screen where they see only the source that they chose, and they're asked, if this source gives you an orange signal, what do you choose? On purple signal, what do you choose? In this example, it's follow the signal, orange on orange, purple on purple. And then they get a feedback screen. This was the state of the world. This is what happened. This is what you chose, the realization, and your payoff. So they do this for 40 rounds, 10 rounds for each prior, and the priors are identified by colors to help them separate the situations. And then they move on to the second stage. And in the second stage, you see the prior, you see the advisor, sorry, here. The prior on top, the advisor, and then we ask you for the posterior probabilities. If you get an orange signal, what is the probability of the triangle being orange or purple, and the same for a purple signal. And now for the other advisor, so they do this for all priors, combinations of priors and advisors. Then they move to the third part where again they see the prior and the advisor, and they ask what's the probability that this advisor with this prior is going to send the orange signal or the purple signal. Okay, and for the other advisor, and that's it. That's the standard stuff, long experiment, high pay. And these are the results. So we see the two treatments here, and what we see on the y-axis is the frequency of choosing the unbiased. Now, and we see as the priors go up, they are less likely to consume the unbiased information. Right? And this is consistent with the difference in expected utility, because as we remember, when the priors go up, then the biased source gives more the expected payoff, expected utility, so it's chosen less frequently. We also see that when the unbiased information is more informative, on the right-hand side, it's chosen more frequently. But this is not about using information. This is just choosing the source. Of course, you can get the information and then ignore it. And if you remember, the value of the unbiased information goes up and down as priors go up. So we should see an inverse U-shape, which is what we see when we separate to, now in green we have getting the information and using it, and in yellow getting the unbiased information but ignoring it. And here we do see the inverted U-shape. So we see that the decisions, they somewhat track the value as they should, but there are other things going on here beyond the value. Right? So this downward slope in choosing the unbiased, this comes from expected utility probably, and not from the value. So to formalize it, we estimate a logit model. So this is just which source they choose. We have here the parameter alpha is just tendency to choose the unbiased. And then we look at expected utility and value, and they're weighted by this lambda. So I don't have time to go over it. I just go to the estimation. So these are the numbers that we estimate. A few things to see here. So the alpha is positive, right? Which means they are more likely to choose the unbiased, fixing expected utility and value. And we see that there's positive weight both on expected utility and value, right? So just to make it clear, for a Homo economicus who's only interested in maximizing the expected payoff, this is going to be 1, this is going to be 0, and this is going to be 0. and the precision parameter is going to infinity. So we see deviation, and then we can do some back of the envelope calculations to understand what's going on. So if both sources have exactly the same expected utility, which also means they have the same value, then from informational point of view, they are exactly the same. So they give you exactly the same posteriors. Then people are more likely to choose the unbiased. Okay, so this is something that looks like non-instrumental value for unbiasedness. If there is instrumental value, both of them have positive value and different, then the biased source needs to provide 15% more utility than the unbiased source to be chosen with the same probability. So again, looks like non-instrumental value for unbiasedness. Important thing is, if none of them have instrumental value, the value is 0 for both, then this number changes, it goes up. And this illustrates the point I foreshadowed, that the non-instrumental value is different depending on whether there is instrumental value or no instrumental value. So again, so all these papers that looked at non-instrumental value in a situation where there is no instrumental value, that's a great strategy for showing existence of non-instrumental value, but this doesn't carry over perfectly to more broad situation where there is also instrumental value. So looking at posteriors, we did lots of stuff here. I don't have time to go over it. Bottom line is, first we can identify two types. One type, prior-based, these are people who just stick with the prior. So you tell me that the prior is 40%, you give me this confusing signal, I don't understand it, you ask me for the probability, I just say 40%. The other type, and these are distinct types, are the Kahneman-Tversky representative heuristic people. So if you remember the Kahneman-Tversky stuff, these are the people who think that the geeky guy is an engineer, although they know the room is full of lawyers, or the guy in the suit is a lawyer, although they know the room is full of engineers. They just go with the signal and they ignore the prior. They neglect the base rate. That's base rate neglect. An important thing here is that we see that people, in the posteriors, they update more on unbiased compared to biased. So there's lots of stuff going behind these slides. I'd be very happy to discuss it at the Hangout later. But to illustrate this last point, it's easy to see. What we have here in the columns, we have the objective value that we can calculate using the Bayesian posteriors. In the rows, we have the expected value given their subjective beliefs that we elicited. And we see several things. So if we look at the biased source, when it doesn't have any value, then most of the time their posteriors indeed indicate that it has no value. But if the biased source has value, then the subjective posteriors still imply positive value most of the time. And we see the opposite with the unbiased. When the unbiased is valuable, it has instrumental value. The posteriors say it has instrumental value most of the time. But even if the unbiased doesn't have instrumental value, it gives you no advantage over following the prior, half of the time they estimate the posteriors, they update too much, and it looks like it does have value. They place the posteriors on both sides of the 0.5. So they underestimate the biased, overestimate the unbiased, and now the obvious question is, can this explain what we see in choices? Right? We see that they are more likely to choose the unbiased. It looked like non-instrumental value, but maybe from their point of view, there is instrumental value because a lot of the time they overestimate the value of the unbiased and underestimate for the bias. So to see that, we look at all strategies, right? So the possible strategies are pick the unbiased or biased, and then I can just ignore it and choose red, ignore it and choose blue. I can do what the signal tells me to do. And actually, I can go against the signal, guess blue if I get red, guess red if I get blue, but that's pretty stupid. And as you can see, they don't really do it, so we pretty much ignore that. What we see here is the ranking of the strategies based on the expected payoff. So green is always whatever strategy it is that gives you the maximum expected payoff, the highest probability of guessing right. So if you're Homo economicus and you just maximize expected payoff and you know how to do Bayesian update, everything should be green. And we see there's substantial deviations. The exercise we do here is we say, okay, let's recalculate the expected payoff, but now using the probabilities that they reported. So from their subjective point of view, if they are maximizing expected payoff, when we switch to this definition, everything is going to be painted green. And does that happen? Well, no. Okay, so the subjective beliefs, although they go in the same direction, they cannot explain the systematic patterning choices. To do it formally, again, we estimate a logit model. So this is a structural model predicting the probability of choosing a strategy. And we're going to allow for two things. One is we calculate the expected utility either using the objective Bayesian posteriors or the subjective beliefs that we elicited. The other thing is we're going to allow for non-instrumental sort of utility for following a source, for hearing unbiased information, and for following unbiased information. Again, I don't have time to go actually out of time, but this is the last substantial slide. This is what we get. People like following a signal. They follow the information too much. It's hard for them to ignore the information. They like to hear unbiased information even if they ignore it. So even if they ignore the information, they are more likely to get the unbiased than they should based on expected utility. And the last thing is, beyond that, on top of that, they like to follow the unbiased information more than they should. Okay, so just quickly to sum up, we see that people follow the highest value, generally speaking, but there are systematic departures from the baseline prediction. We see that people overestimate the value of unbiased information, underestimate the value of biased information, but this cannot explain why they choose the unbiased information, why they like to hear. So it's like unbiased is good in two versions, in two directions. Like you think NPR, if it's unbiased, is more valuable than it is. You also like to hear it and follow it, but these are two distinct effects. The first cannot explain the second. More broadly is that what we see is at least consistent with non-instrumental preference for unbiased sources, but we see that this varies whether there is instrumental value or not. So like the broad message here is that non-instrumental value is not a characteristic of the decision maker. It's a feature of a combination of the decision maker and the decision problem. So that's like the broader, more important message, and that's it. Thanks. So we have a few minutes if you have comments or questions.
Roy, what was the environment in which they did not ask for non-instrumental information? So how do you contrast your findings to those in the literature?
So there are examples where, you know, there is a state of the world, you're going to get a prize or not get a prize, and now you can choose a signal. So you have no effect on that. There was a lottery, you either got a prize or didn't get a prize. The question is, do you want to know now? Do you want to hear bad news? Do you want to hear good news? Mm-hmm. And the other context is there are two information sources, but whatever it is, whatever signal you get, you're going to make a decision, but it's always the same. Okay. Right? So that shows that Kfir has this paper where it shows you want to get better information, like more Blackwell information. Okay. So do you want to know that your chances of winning are 0.3, or do you want to know whether it's 0.1 or 0.5? Or sorry, or let's say, is this good for 0.3 or 0.2 or 0.4? Either way, you're going to choose the other direction. It's never going to make you change your mind, but you get a better knowledge of what's going to happen.
Okay, again, and in which situations in your context they do not want this non-instrumental?
This is we see
always
non-instrumental, but we have situation where there's no instrumental value. So this is like the low prior with the prior 0.1 in our case is sort of like these older papers. Because if the prior is 0.1, you're going to guess blue, no matter what happens. But they still like to hear the unbiased information.
Okay.
and also they like to follow it to some extent. So this is the case where none of them has values. That comes from the low prior.
Yeah, I'm just getting back to your example. I mean, we see more news sources are becoming more biased. I mean, and I guess that makes sense for directed advertising, but in some sense, your results go in the opposite direction, that people wouldn't, you know, my mom wouldn't want to watch Fox News. You know, she would want to get a news source from something unbiased, but they seem to want, you know, so your results seem to go opposite of what sort of the, you know, what the intuition is what we see out there. So maybe it just shows us that they're not getting it for making decisions. They're not watching the news for decisions, maybe entertainment or something. I don't know.
Yeah, so there are lots of other stuff going on, right? And you can have confirmation bias of the psychological sort, that you just like to hear pleasant stuff and not for instrumental value. That's true. I have to say, I'm not sure my co-authors would agree with this example. That's just for this talk. Yeah, so there are lots of other things going on, and here we focus only on the information characteristics. But again, but you should also consider the instrumental value, right? So it's possible, because usually if you have a strong prior, then the bias in your direction is going to give you more instrumental value. So maybe you trust the unbiased more, but you still get more instrumental value, and that drives decisions. So that's also possible.
Yeah, I mean, but in some sense, I guess your theory says you should be watching more Fox News than NPR, but in practice, people are not.
Not as much as they, when we control for instrumental value.
Yeah, yeah. Which is a bit surprising, because you would think that there might, but I guess this is context free, so maybe that's it's all going from context. So and I also just completely, a different aside is that normally in conferences, we see the last session being somewhat empty because people have to catch their flight home. I wonder what the excuse is here.